Hello friends, myself Bharti Gupta, faculty in Organic Chemistry. Welcome to my class of Organic Chemistry. Today, we'll learn something about optical isomers. So what are optical isomers? Optical isomers, from the name itself, it is clear it is an isomer. As we say isomer means compounds having same molecular formula. So as we use the word isomer, it is very clear कि molecular formula is same. So one thing is very clear, if optical isomers means compounds will be having same molecular formula. Optical isomers are type of stereoisomers. Now what do you mean by stereoisomers? Stereoisomers means compounds having same molecular formula and also same structural formula. For stereoisomers, structural formula is also same. The molecular formula same, structural formula same, and IUPAC name is also same. So what is difference? What is the difference between the two compounds whom we say stereoisomers? Difference is in 3D orientation. 3D orientation of atoms or groups in space. Two molecules having same molecular formula. Same molecular formula, same structural formula, same connectivity of atoms and having same IUPAC name. But differ in 3D orientation are called stereoisomers. Optical isomers are type of stereoisomers. So what specifically is this type of stereoisomer which we call optical isomers? So how we define optical isomers? Optical is something related with light. So now two compounds, suppose we are having two compounds A and B, and if these two compounds are having same molecular formula, same structure, same IUPAC name, but they differ in their properties, and reason of difference is property is 3D orientation of atom or groups. We say they are stereoisomers. Now among the stereoisomers, if we want to say that they are optical isomers, so what must be the basic difference between A and B? If we are saying these two are optical isomers, is they differ in their behavior towards light. They differ in their behavior towards light. Means if we are saying two compounds A and B are optical isomers, it is very certain that they will show different behavior towards light, and from the light the word is coming optical. Now what is the meaning of difference in behavior? What do you mean by they show difference in behavior towards light? Now suppose we are taking a compound and through that compound we are passing some light. Okay? And if that compound affects the light in any way, what kind of effect it will show, that we'll see later. But if that compound affects the light in any way, we say the compound is optically active. And if a particular compound do not affect a light, no effect on light, we say the compound is optically inactive. These two behaviors, which two behaviors? Optically active and optically inactive. These are two different behaviors. So this is difference in behavior towards light. In behavior towards light. So if a compound, suppose we are saying A is affecting the light, we can say A is optically active. Now compound B is not affecting the light, B is optically inactive. These two compounds are having same molecular formula, same structural formula, same IUPAC name, but one is affecting the light and the other one is not affecting the light. It clearly means these two compounds are optical isomers. So optical isomers simply means stereoisomers. Stereoisomers having different behavior towards light, they are called as optical isomers. Now the difference, what is the difference in behavior? One is active, one is inactive, or it might also happen that two compounds are optically active but they are affecting the light in different way. One is having some other effect on light and the other one is having some other effect on light. Then those two compounds, if will have same molecular formula and same structure, then they will also be called as optical isomers. Now in lab we can experimentally decide whether a given compound is optically active or inactive. So the instrument which is used to measure optical activity, is called polarimeter. So polarimeter is an instrument by which we measure optical activity of a given compound. We come to know whether that compound affects the light or not. If affects, what is the effect of light and that? What is the magnitude? What is the direction? That all we can come to know by an instrument which is called as polarimeter. And for that, we will see the experimental setup, how polarimeter works and what are the observations we get in polarimeter and how do we interpret that observations from that observations about the optical behavior of the light.